Okay, in today's session we're looking at arithmetic sequences. So something like this, for example, is an arithmetic sequence. And so on. You could have something like this as an arithmetic sequence as well. So let's go. Okay, so there you go, there's another arithmetic sequence. So all these things like this is an arithmetic sequence. Could also go something like this as well. Okay, so an arithmetic sequence doesn't have to increase, it can decrease. But in all of these, in each of these things, when we look between the terms and we have a look in all of these sequences, what we notice in between those sequences is that there's what we call common difference. Okay, so in the first one, of course, the common difference is 2, we're adding 2, the second one 8, we're adding 8, and the third one -5. Okay, so of course if we want to find the term number and have a functional definition of one, then say for example we just look at we'll just look at the sequence. So let's look at the sequence 10, 12, 14, 16 and so on. If you look at the term number is 1, 2, 3, 4 and so on. So the term number, we've got 10, 12, 14, 16 and so on. Well, what we've got here is 10 for the first one. Here we've got 10 plus 2. Here we've got 10 plus 4, which is 2 times 2. Here we've got 10 plus 6, which is 2 times 6. 2 times 6, what am I talking about? 2 times 3, or 3 times 2. So that first one here, or the second one, term, is 1 times 2. Now when we have a look at our term numbers, and the number of times we're adding 2, you notice that there's one difference in there. So from this we can deduce that any term number, term n, for this particular one would be 10, our starting number, plus, well, it's n minus 1, isn't it? Times by 2. So if we want to go to a general form, term n equals a plus n minus 1 d, where a is our first term and d is our common difference. Like so. Alright, so let us now have a look at some examples of some things. Alright, so let's have a look. Show the sequence is arithmetic. Okay, so to show the sequence is arithmetic, let's write them down first. So sequences can be any form. So here we've got polynomial sequence. And so on. So what we need to do is we need to look at the difference between these things. So let's have a look. This one here, the difference 3x minus x squared is 2x squared. negative second x minus negative 4x, negative 3x. Next one, have a look. So we got 5x squared, we're taking 3x squared, which is 2x squared. We then got negative 10x and we're taking away negative 7, so negative 10x plus 7x is minus 3x. And those two are the same, so therefore it is arithmetic. Okay, so that's all you need to do is just check that. Alright, let's have a look at some more examples. State which arithmetic and write a functional definition. Okay, so for the first one, part A, 2 is 4, 9, 15. Then B is negative 2, 1, 4, and so on. So we're going to look at that. Look at the difference between there is 5. Distance between here is 6. So that one's not arithmetic. When we look at the next one, here we're adding 3, then we're adding 3 again, so it's arithmetic. For a start, so if we're going to write a functional definition, we need to know A, the first term, which is minus 2. We need to know our common difference, which we've said is 3, positive 3. So term n then equals A plus n minus 1 times D, and so in this case it's negative 2 plus n minus 1 times 3, which you probably would write as negative 2 plus 3 n minus 1 for that one there. Okay, arithmetic mean. Alright, so arithmetic mean is kind of numbers in between. So for example, we've got 3 terms, x, y and z are our 3 terms that we've got. What do we know here is that we add d and we add d. So from that we can deduce that then y is in the middle. So if y is in the middle, then y would just be the average of those two. So for any 3 consecutive terms, the arithmetic mean, which is what is z, is the z, y is the arithmetic mean of x and z. It's just the number in the middle. So if we have an example, for example, find the missing terms. Okay, so for example, we've got 41A, 55B, and so on. So we need to find A and B, obviously. And A, of course, is the term in here, is the term in the middle of those two. So A is just going to be the arithmetic mean of 41 and 55. And the arithmetic mean of 41 and 55 when we add it together is 96. Half of 96 is 48. So A is 48. So from that then we can deduce that the common difference is 7. So from that, B would be 7 more than 55, which should be 62. And so A is 48 and B is 62. Alright, now let's do something a bit more tricky. To amp things up. Okay, so find the 16th and nth terms in the arithmetic, and that's important because there's other types of sequences other than arithmetic, so that's a key word. Sequence is fourth term 15 and 8th term 37. Okay, so A and D is not what we're given, but we need them. But what we do know is term n equals A plus n minus n minus 1d. So we've got some information. We know that term 4 is 15, and that equals A plus 4 minus 1d. So 15 equals A plus 3d. And we also know that term 8 is 37, and that's A plus 8 minus 1d. So 37 equals A plus 7d. Okay, so we get two equations here, and whenever we do two equations we solve simultaneously. In this case we can do 2 take 1. So when we do that, 37 take 15 would be 22. A take A is 0, 7d take D is 4d. And so that then means that D is 22 over 4, 11 over 2, or 5.5, whichever we like. So now we need to just go and substitute that into something else. So we can substitute it into, say, term 4, for example. So A plus 3D equals 15. And we've just found what D is, so it's A plus 3 times 11 over 2 equals 15. So 33 over 2 equals 30 over 2. And so A is negative 3 over 2. Alright. Okay, so now that we've found that, we can find those terms. So it's probably easiest if we find the nth term first. We have to find term n and term 16, I think, if I remember rightly. Yeah, 16th and nth, n minus 1d. Well, we now know that A is negative 3 over 2 plus n minus 1 times d, and we now know that d is 11 over 2. So that's probably going to be written as negative 3 over 2 plus 11 over 2 times n minus 1. Now, we can, of course, expand that out. So if we do expand that out, we've got negative 3 over 2 plus 11 over 2 n minus 11 over 2 minus 3 minus another 11 is negative 14 over 2, which is negative 7, plus 11 over 2n. Alright, there's all different ways that you could express that. One of them is 11n minus 7. Oops, not minus 7, minus 14 when I'm going to do that. Minus 14 over 2. And there's many different ways that you could write that, and certainly expanding it out and then simplifying as much as possible is definitely the way to go, because that's where you're expected to be going with your answers in the exams next year. Alright, always in the simplest form. Okay, so term 16, of course, we just need to do 11 times 16 minus 12 from that, put it over 2. And when you do all of that, you get 81 as the answer. Alright, so there we go, there's arithmetic sequences. Put in that, so you're now up to the questions for exercise 6b, that's set number 2.